Satellites spend their entire life in a state of motion. Yet for all our knowledge of physics and orbital mechanics, we as a nation and a profession worldwide struggle with predicting satellite maneuvers, and perhaps more importantly, understanding why a satellite of interest has moved. Space analysts and leadership consume immense resources explaining and predicting satellite maneuver as guesswork and speculation perturbate the decision-making process. We believe the ability to explain and predict satellite maneuvers is hidden in the data. We just can't see it yet. I'm Tim Haney, CEO and founder of Spectrobotics, a data aggregation, analysis, and visualization company headquartered here in Colorado Springs, Colorado. We provide predictive analytics services to smart city and smart agriculture customers to find hidden efficiencies and insights for streamlining operations. I want to give you what we believe is the solution for how we can solve this space problem for our national and our commercial space community, and be on the ground floor of a whole new industry, smart space. So let's get right to it. How do we get to why a satellite is maneuvering? Well, it comes down to understanding two key inputs: past behaviors and current conditions. And let me walk you through the data processing method we use, or we believe, can bring these two inputs together to solve for why. Now, the first challenge is to mathematically describe why satellites move in the first place. And there can be any number of reasons. For example, space weather may be causing changes to antenna pointing. Orbital decay requires a station-keeping maneuver. Or perhaps a change in the satellite's mission requires a change to its orbit. In most cases, these events are normal. Monitoring this activity gives us a crucial piece of the answer: pattern of life. Now, pattern of life to us is really a mathematical and process-oriented way to describe repeating activities derived using a pioneering technique called process mining. Now, like many data tools, process mining had its early beginnings in the business intelligence community as companies looked to gain efficiencies and spot market opportunities. In process mining, you take time series data and you analyze this data using explainable AI to derive emergent patterns and behaviors. These patterns and behaviors become the historical context that we use to understand how something is likely to behave. Now, consider a satellite routinely performing a weekly maneuver. It's easy to associate a time frame to a predictable event or an explainable event, but often it's not that simple. In fact, most satellites perform a variety of maneuvers even under similar conditions, from impacts like solar radiation pressure, the Earth's magnetic field, or atmospheric drag. Process mining discovers these events as patterns and then maps these behaviors in a diagram of possible inputs and behavior outputs. When conditions are right, using this diagram, we use weighted options to predict a likely pattern of activity that can be associated to a predictable outcome. But remember, we're working to determine why a satellite is or about to maneuver. Many of these patterns are not connected to a single frame reference. The space environment is highly dynamic, and business and target opportunities come and go, and security for our space assets changes constantly. How do we sift through all of these variables to determine when conditions are the impetus for a change in behaviors? Here we are at the second challenge. How do we understand the current or future conditions that precipitate a maneuver? You see, to understand how to classify conditions that predict outcomes, you need to analyze lots of diverse data related or seemingly unrelated to the satellite environment and operational conditions. This is where deep learning gives us the ability to analyze the data to discover connections, relationships, and patterns across the data structure that gray matter analysis just can't provide. This gives us a real-world feel for conditions not necessarily programmed into a simulation. By understanding these conditions and assigning classifications based on things like time duration, intensity of activity, frequency of occurrence, we get access to information about an object that's far beyond what is typically maintained in some historical description of events. From this deep learning, we get data models that are basically describing conditions that lead to changes, using a mathematical language to represent those connections and associations throughout the data sets. And here's the best part. Deep learning enables subject matter experts in space weather, orbital mechanics, or threat systems to lend their expertise during the training process for the analytics to classify these conditions with greater accuracy. These classified conditions are what set in motion the describable events discovered through process mining. So ultimately, what we do is enable experts to connect the dots between events that happen in space to events that happen in other domains. Smart space, smart city, smart agriculture, there are common threads among them all that we find beautifully suited for our data services. In each of these, users must understand why something is happening in order to take necessary steps that maximize yields or provide safer streets or better protect critical space infrastructure. The ability to aggregate, analyze, and visualize data solves the central challenge, slowing progress towards truly smart applications throughout these opportunities. So we talked about the problem and how we can solve it, but really, why us? Well, for starters, I lived this problem for 11 years as an Army space professional. 2 more years past that as a contractor for the Air Force, 6 more years past that building tools to solve this very problem. We've earned grants from the state of Colorado, won state coding competitions using dusty old data, and we've been selected as a top 10 finalist over companies from across the country for NASA's iTech competition. And we've already begun bending metal on this concept for smart space. We were awarded a Phase 1 SBIR from AFWERX to assess the feasibility of combining our tools to address space challenges related to monitoring satellite behaviors. Outside the Air and Space Forces, we've gotten the attention of the Defense Threat Reduction Agency as a way to better forecast unforeseen threats to space assets. At the end of the day, this is where we're working to get to. This represents where we spend our time making decisions. Routine decisions are cheap. They're made all the time and at lower levels. Reactive and initiative decisions are expensive and happen more frequently when we have untimely or incomplete information or gaps in our domain awareness. Better data tools, focusing analysis on predictive events, even providing greater access to analysis grows this routine decision making and gives time and resources back to leadership to address other challenges. Now, admittedly, these data tools are only part of the solution to bigger problems in space. We can't build this without institutional knowledge. And just like this image, recognizing patterns is something our brains want to do. We just can't see the patterns in the right context until now. Whether it's smart city or smart agriculture or smart space, collaboration is key to how we solve these problems. So please connect with us after today's presentations and let's talk about really big ideas. Be safe, everybody, and we look forward to talking to you after this. Thank you.